Okay, I'm between you and the networking, so I'll be quick. I talk about how we implement a responsible AI framework in the company. And this is not a technical question. It's an organizational governance question. So this is what I will mainly talk about. But there will be a bit of technical in there to show how difficult that actually is. So what's modern AI? What are we actually doing? We're using data and machine learning to automate decision making. This is what we're really doing, right? And I like this quote from Cassie Kozyrkov: machine learning scales stupid. So, or in another way, what you're doing is automation. And when you do any form of automation, you always have the chance to make more mistakes faster. And this is where responsibility comes in. So you want to make sure that you do not make a lot of mistakes, especially not of the type that impacts your brand or the ethical kind of things that you're actually doing. The way we try to contain this is testing, and more testing. And this is kind of the workflow that we have defined for ourselves, what we go through when you build machine learning models. So it's not a kind of a tooling or a kind of what you do in a cloud environment. This should apply whatever you're using, whatever tools you're using to build models and release them in production. And your opportunities to have interventions to pick up anything that might go wrong. And you should do testing everywhere. And ideally, you start at your data, right? So you should prevent wrong data going into your repositories. Then obviously, you do versioning at every stage. When ideally, you version your data if you can. But anytime you write any sort of software, you query your data, you write scripts, you build models, all of this obviously gets versioned. And you have testing throughout the whole life cycle. And testing means these kind of things that I have listed there. But you also test, for example, for bias and fairness at every stage, because it can creep in everywhere, right? So if we take this as an example, fairness of your algorithm or avoidance of bias, you need to check in your data, you need to check after you have wrangled it, because maybe you have unconsciously put bias back in. When you pick the features, when you build your models, at every stage you can test for these kind of things. And especially in life and when you make decisions, you need to test for these things. And in any kind of environment that you're using, any kind of cloud environment, GCP, AWS, whatever, you have only limited support for these kind of things. You will have to build yourself something, and you have to configure yourself something that makes sense and works for you in your organization. In BT, we have a responsible tech framework, which is part of our manifesto. And so we have these 4 pillars. Technology should be for good, it should be accountable, it should be fair, and it should be open. And from this, we derive how we control responsible AI in the company as well. So AI is just a part of tech. And the way we do this in the company, we have written what we call an AI Builder's Guide. So it's actually sitting down, writing a document that machine learning engineers, data scientists, and the like can read and understand and know what they should follow when they build models and release them. And we're going to turn this into an internal standard as well with controls and everything. So that starts with the insight that anything we do follows our responsible tech guidelines. So it's part of a wider corporate framework that you need to have in place. Then when you start, you ask yourself, what's the intention? Should I be doing this? And if you answer, yes, I should be doing this use case, should I use AI to do it? Or should I use something different? And what are the risks and accountabilities? Can I use the data that I want to use? All of these kind of things. So internal other governance processes like privacy impact assessments and so on kick in at this stage. Then responsible implementation means ensure data quality, check for fairness, continuous testing at all stages, and so on, what I mentioned already on the previous slide. And then diligent production and monitoring, and a lot of speakers today have point to this, that you should monitor your models in life, and may have said how you can do this, checking for drift, these kind of things. So you would also monitor your decisions to prove that you add value to the company, and this is also the opportunity to check, are you making any mistakes, or are you introducing bias again? You should have an end-of-life management process, so when you take models out of production, you should still be able to say which decisions have been processed by this model, so you can go back, because maybe in a couple of years' time, somebody is going to sue you for something that you have done in the past, and you then need to find out which model was it, who built it, what was it built for, what decisions did I make, and so on. We are working with other organizations, other telcos, and different kind of industry organizations on how do we provide support in this sort of process. So one thing that we have done with a telemanagement forum, which is a kind of a club of telcos and suppliers worldwide, we have developed very simple checklists. So it's kind of a checklist that a pilot would go through before they take off. So just to remind people in the process, what is it that you should be doing when you build a model for decision making, when you deploy it, have you done all of these things? So it's not supposed to be a check, it's not going to be recorded, it's not going to be kind of a mandatory process. It is something that you can hand to people. You can actually print it on cards and give it to people so they remember. Particularly useful for people that come new into the company, so they know what sort of process you're following. And you can adapt this to your own needs, of course. We're also working on how do we do high-level model management. So we can do AI governance and AI management. And there are concepts out there. Google has model cards. IBM has something similar. So there are different concepts of tracking what models are doing. And we are looking into what are the actual points you should be tracking, and what's the data model for tracking these things, and how do you then automatically generate this data and track it automatically, because one of the issues is anything that needs to be done manually in the process gets shortcuts, right? People don't do it, and you don't find the information. So how can you automate these things? How can you populate these? We call them model data sheets automatically. But essentially, it's the same idea as model cards. And let me just look at fairness as one example of the governance process and responsible AI, because this is talked about a lot. Bias in AI models is discussed in the media regularly. And if you're not familiar with the area, I recommend you have a look at the Algorithmic Justice League and the work that Joy Buolamwini is doing there, who has kind of written the first kind of analysis of bias in AI in facial image recognition. When you ask yourself, is my model fair, then it's not just a data problem, it's not just a statistical problem or a metric problem. You should look at it from a wider angle. So who collects the data, who writes the code, who operates the AI, who is targeted or who has access to the model, and who is auditing the model. If you look at it in a more kind of technical manner, and kind of it's typical for the kind of computer science, data science field, right? If we want to track something, we write a metric. And so we have looked at these fairness metrics that you can use. And we used IBM's AI Fairness 360 software, which is open source. You can use it yourself. So it's great that something like this is available. And so what you need to do is you can use the software, you decide which fairness metric you want to track. And this is the first problem. You have more than 70 metrics you can pick from. So how do you know which fairness metric is good for you? Which one should you use? And they're obviously largely incompatible with each other. So you can only be fair in one aspect, and you will be unfair in other aspects. So you need to identify for the organization, for your use case, what does it mean to be fair in this particular use case? And even if you have decided, yep, that's the metric I want to track, then come the technical problems. So what we have done here is we have tried it. We have used this IBM tool, and in there you find something that's called a metafair algorithm. This thing can train a model for you, a classifier for you, and you can specify a fairness metric. This one can only use 2, and we used disparate impact. Disparate impact means you check the probability for each group that you want to be fair to. What's the probability that it gets a positive label? And the ratio between these, if you have 2 groups, should be 1, ideally, then you're completely fair. Now, in order to use this, you need to set a threshold. How fair do you want to be? So this threshold is something that you need to put into the algorithm. And what you see here on the left is the threshold. It's called tau in the model. And you see the accuracy that results after the model has been built as you vary this tau. So we used the adult data set here, the public domain benchmark data set, and we used the sex as the protected groups. So we had 2 groups. And then we used a training test split and built a model and using an XGBoost. And as you vary the tau, you can see there's a slight downward trend in terms of accuracy, which you would expect. The more fairness you get, the more you will suffer with accuracy. But you can see that small variations in this threshold can lead to huge changes in accuracy. And so you cannot just pick a value for tau. This is a very small data set where you can very quickly create hundreds of models to check what the impact is. If you have a massive data set with millions of data rows, maybe you do 3 or 4 experiments to pick a good value for tau. And then you get very nice looking curves, and you think, okay, I'll set tau to this level. This is a good trade-off between fairness and accuracy. But you don't see the actual detail. And when you then release this in life, the data fluctuations you have naturally by getting new data through the algorithm will mean you're sitting somewhere on this line, and your accuracy might suddenly tank or go up, and you have no control over this. The charts on the other side are a different experiment. We used the calibrated equal odds processing algorithm in this tool, which is, well, metafair implements fairness during the model build. This algorithm does it after the fact. It changes some of the outputs of some of the patterns based on probability. And what we did here is we used one fairness metric and optimized for it. And we optimized for minimum difference in the false negative rates for the 2 classes, for the 2 groups that we wanted to be fair to. And we are plotting the difference of the true positive rates for the 2 groups. And the red curve is the original, and the blue one is how the model has been changed by the fairness algorithm. And so you can see that the fairness metric typically gets better. It's the blue curve. So what you're doing here is you're looking for a classification threshold that you would use. So a smaller value is better. Right? That's the difference in true positive rate. So you would pick a classification threshold that makes the equal opportunity difference as small as possible. If you run different training test splits, so we tried hundreds, you get completely different pictures, so it's not consistent. So on the first one, you see you should take a classification threshold of 0.35 or something. Then in the next one, it's 0.65. And in the other one, you see that the changed model is actually less fair than the original model. So this can happen as well. And these effects you will get even if you build yourself something that you're happy with, because the data that you put through later when the model is live will create these sorts of effects. So that means you need to constantly keep monitoring for this. You can't just decide, okay, I'm using this fairness metric, I'm using this threshold, tick in the box, deploy model, forget about it. That's not going to work. You also should take a wider view. It's obviously you need to know the protected attribute if you want to be fair. If you don't have them, you can't do this, but you will have secondary attributes. You all know the story of Amazon and CV scanning that went horribly wrong. So secondary attributes correlate with protected attributes. So you will get bias in through the back door. How do you manage this? You can get spontaneous bias formed by random attribute groups, especially if you use tons of features and your features are not really making sense for the application, but you use them because you have them, and there are weak signals in there. That's why you keep them. But you can get effects like that your model, for example, is biased against certain hair color and shoe size, assuming you have this in your data. So how do you find these sort of types of biases? Then obviously, is your use case fair? Should you have this use case? And what about group fairness versus individual fairness? So some of these metrics tune for group fairness, but it doesn't mean that you're treating individuals fairly. How do you manage this, and how do you mitigate for this in the application process? Coming back to corporate governance, you need to figure out what could possibly go wrong. That's the kind of question you need to ask yourself. And there are different levels in the organization who need to take action. If you're the business leader, then the buck stops with you. And a lot of board members or CEOs are not really aware of these things, right? They think this is handled somewhere down in the organization in the data science teams. But if they don't do it, it goes all the way up to the business leader. That means the business needs to set the red lines. We're doing this and we're not doing this. And if we're doing something, this is how we're going to do it. And these red lines need to be propagated down. Typically, in organizations, you have a risk management process that does certain things of this already. So all companies now have implemented GDPR, and they have processes for that in place, right, to make sure that they're not using data that they shouldn't be using or collecting data in the wrong way. And these processes you can reuse for managing your AI models. Larger organizations definitely have risk and governance teams, and they are on point to implement and control these sort of processes, but they need to be brought on board. They need to understand what are the actual AI risks that we're having when we're using models. There will be a product owner who needs to identify and own the risk for the AI product. And the data scientists, they have to describe the limits, the restrictions, and the assumptions when models are being built. This model has been built for this purpose. Do not use it for anything else. These are the assumptions I've made when I built this model. And this is where it will work, and this is where it will not work. And these kind of, this sort of information needs to be surfaced. So responsible AI is an organizational policy, and it's enforced by a diverse team. Diversity in terms of roles, and ideally diversity in all sorts of dimensions, because you want as many eyes on this with different opinions and different experiences as possible. You can't leave it to the data scientist. So if you're the data scientist and your boss tells you you are responsible for fairness, then say, nope, I'm not. I'm only responsible for some of it, and there's more to be done. Unfortunately, the AI industry, my opinion, is still snoozing. We are not getting the right level of support in the tools and software that we are using to build models and release models. There's still this attitude, if it doesn't work, go large. Right? We're building larger models using more data, which is, we just heard it before, we're heating the planet if we have this attitude. We shouldn't be doing this for this reason, but it's also less controllable and less transparent. There's a certain intellectual laziness in the AI industry, meaning try and see what works. I don't really analyze it and understand why it works and what are the repercussions. And there's this accusation that we're doing alchemy instead of science, right? This is not something I came up with. It has been said already in 2018 and at NIPS. So are we really understanding when we're building deep networks what these things are doing, and if this is the way we should be doing it, or are we just taking something that works for some reason and we don't really know? So from the AI industry, I would expect the right kind of tools and levers that help me to control this space. It's not that they can chuck something over the fence and say, here you go, build your models, and it's on you to make sure they are fair and responsible and all of these things. I expect a responsible industry to give me the right control levers for it. It's kind of if you build an airplane and you source the parts for it, right? The responsibility that the bolt doesn't break mid-flight is with the manufacturer of the bolt. You're not expected to take the bolt and test it yourself anymore. AI regulation will come. The gold rush is over. We have to get serious. We have to get real. In a few years' time, there will be regulation. And if you look in the current drafts of these regulations, there are things in there that says your data and models should not be biased. You should explain your model outcomes. But if you are honest, you can't do these things, right? You cannot guarantee that your data is not biased, and you will not be able to explain your model outputs. So it's time to think about these things. It's also time to engage with the regulators and tell them this is what's currently technically possible, this is what's not possible, and regulators need to think how to iterate the regulation and what to write into it. So you need to be prepared to be audited on your AI. So if somebody comes to you and says, oh, please show me how you built this AI model, how you have used it, what decisions have been made, how do you know it's actually working? These sort of questions at some point might come. And then you better have everything ready to pull it out of the drawer. You don't then want to start and scramble and find out, oh yeah, how did I do that? Formal methods won't solve something like AI fairness. So it's not going to be something where we can press a button or use a metric. It will require more kind of effort. It will require kind of what we would call like soft methods, social science methods. Risk and governance need to be applied in this space. Vendors need to build these hooks in. We rely on the vendors to provide the levers and the means for us. Businesses need to define what the red lines are and have governance in place. And regulators, as I said, they need to iterate. And we also need sandboxes where we can try out stuff, regulatory sandboxes. And it requires a dialogue. So we can't, as if we say we are the AI industry, we need to engage in this discussion and work with the regulators. And regulators do not necessarily have the technical background to really understand what this space is all about. All right, thank you very much for your attention and happy to answer any questions you might have.